Okay, so we're back for day 2 of integration. But before I start, I would like to sincerely thank all my viewers, especially Tarun and Vedant for dropping comments, and especially I would like to thank Hitesh for giving me 180 views from the same channel by rewatching my video again and again. So, in his honor, I will be integrating today wearing the shirt that I got for him for his birthday. Okay, so this video is specially made for him. Okay, so today's integral for the day is going to be root x dx. Now, if you remember, yesterday we did the power rule, and to revise the power rule, it's x raised to the power n, the integral of this, is equal to x raised to the power n plus 1 by n plus 1. Okay? Now, we have to utilize that same rule again here today with root x. But how do we go about that? So, for this you need to know basic algebra about how root x is written in the form of powers. So, the root x is written in the format of x raised to the power 1 by 2 dx. Okay? So, this is basic algebraic properties, we learned it back in the day. So, root x is x raised to the power 1 by 2. So, now you can see a similarity that there's a power n here and then there's a power n here. And here n is equal to 1 by 2. So you have to simplify root x to get x in the form of power and then solve it. So now we know n is 1 by 2, so we utilize it. We get integral of, okay, now since we're already integrating this, we don't need the symbol here. So we get x raised to the power 1 by 2 plus 1 by 1 by 2 plus 1. Now this is basic fractional addition, so you get x raised to the power 3 by 2 by 3 by 2. Now you can leave the answer in this way, but this is missing two things. Firstly, it's a fraction in a fraction. So it's best to simplify this when you're going to write your answer. So if you assume this as a fraction, you would get 2x to the power 3 by 2 by 3. Because you take the fraction up and then it alternates, it switches. 3 goes down, 2 goes up. Okay, so this is our final answer. But what we learned yesterday was that when you derivate this, you get the opposite. And derivatives can always have a constant at the end of it, because the derivative of a constant is always 0. That's why here we're going to write plus or minus c. And c can be any constant, because regardless of what that is, when we derivate this whole function, we are bound to get root x, and we can try that again today. So we have 2 by 3 which we can take out, and then we can differentiate d of x raised to the power 3 by 2 by dx. Now 2 by 3 is a constant, so we can take it out, and here we'll get 2 by 3, and here you have to use the derivative power rule. Okay, so the derivative power rule is simple. It's so the derivative power rule is x raised to n is equal to n into x raised to n minus 1. Okay, so now here our n is 3 by 2. So I don't have space on the board. Okay, so 2 by 3, we have x raised to the 3 by 2. So you'll multiply by this by 3 by 2 into, well, it's x again, but into x raised to the power 3 by 2 minus 1. Okay, so if I need to get a bigger board, so here we'll get 2 by 3 into 3 by 2, and here everything cancels out, 2, 2, 3, 3. So we're left with x raised to the power 3 by 2 minus 1. And if you do simple fractional multiplication here, we get x raised to the power 1 by 2, which is equal to root x. And the reason we add the plus or minus c is because in this function, if we added a plus 6 or plus 7 or anything, when we derivate it, this will become 0. So even if we have a plus 6 here, when we do the final derivation, we'll get plus 0, which is the same as the answer we have here. So if you reverse engineer the answer we get through integral by differentiating it, you'll get the original integral we started with. So this is the integral for day 2. and tomorrow we're going to move on to other integration properties like logx. So again, thank you Vedant and Tarun for your views. We're going to play Minecraft now, and thank you Hitesh especially for the 180 views that you have given today, and thank you to all my other subscribers. So yes, I'll see you tomorrow. Good night.